Hello, Prof, and thank you for joining us for our final milestone presentation. This is our milestone 4 presentation. So this milestone was made possible because we have just now completed the AI component of our website. While it is submitted late, the delay is reflective of the challenges we faced from half our team being away on SEP or NOC or LOA across the last 2 semesters. So throughout the semester, we've been developing the no AI website and the AI powered website, but we had a lot of bugs and communication hurdles between the team members, and it made us uncertain if we'd be able to finish the AI powered website. Thankfully, we have now resolved those issues and just completed the AI powered website. So this presentation focuses on the AI implementation and builds directly on the last milestone video that we submitted. With this, our project is now complete and fully complete, and we sincerely hope that this milestone video can be accepted. It represents a significant and sustained effort from the technical team members. Thank you. Okay, so this is what our website looks like. Here's a snapshot, and please do check out the website via this link as well as the GitHub repository to have a closer look at our code itself.
I'm going to begin by walking you through the conceptual foundation of our project and how it evolved from initial ideation into a structured implementable solution. This journey started with a noticeable shortcoming in the field of participatory design. Practitioners were innovating constantly, yet the templates they relied on for facilitation were static, hard to adapt, and frequently misaligned with the dynamic needs of actual workshop settings. These templates often lacked flexibility, relevance, and accessibility. It became clear to us that there was an opportunity to build something new, something smarter, and some more responsive to real-world use. This presentation marks the completion of our fourth milestone as IEX2 students. Throughout this project, each sprint has served as a structured opportunity to reflect on our progress, re-evaluate our strategies, and refine our work. Milestones aren't just assessment checkpoints, they represent a full iterative cycle of planning, tracking, reflecting, and improving. These cycles were informed by regular supervisor consultations and collaborative peer discussions that challenged us to elevate both our process and our outcomes. Our first step was to define the actual problem we were trying to solve. Participatory design is supposed to be adaptive by nature, yet the tools supporting it weren't. We believed that better tools will create better practices. So we envisioned a solution, a system where AI could recommend and customize templates based on user input, adapting them into specific use cases in real time and preserving core design logic while enabling flexibility. Our ideation phase was highly creative and slightly chaotic. We discussed everything from real-time collaborative editing features to gamified interfaces, adaptive learning systems, and community-driven template repositories. But we quickly learned a vital lesson. When every idea feels essential, it's hard to focus on what really matters. Applying the SMART framework, specific, measurable, appropriate, relevant, tangible, helped us cut through the noise and find clarity in what we wanted to achieve. Ultimately, we committed to developing a minimal viable product, a conversational AI tool that recommends and edits templates. Making that decision required discipline. It meant setting aside appealing but complex features to prioritize clarity and core functionality. What anchored our direction was a strong sense of purpose, building a usable tool, not a prototype with bells and whistles. That mindset, focusing on our core problem and resisting distraction, guided us through every subsequent milestone and was essential to maintaining direction through complexity.
Was clearly established, we transitioned into the technical implementation phase, what we identified as the execution stage in our sprint cycle. This formed the foundation of our second and third milestones, where the weight of the project shifted from ideation to infrastructure. We explored several tech stacks considering their scalability, compatibility, and learning curve. Flask gave us robust backend capabilities, but its lack of intuitive front-end support increased development time. React, on the other hand, was appealing for its polished interface options, but we were wary of the overhead and integration complexity. We eventually selected Streamlit, a Python-based framework optimized for rapid development of data applications. This decision allowed us to work within a unified ecosystem and reduce friction between front-end and back-end workflows. We integrated Hugging Face for model deployment, which offered seamless connectivity to powerful AI tools. These choices were not lightly made. We used a comparative matrix based on SMART goals, evaluating each option for speed, measurability, simplicity, whether it was appropriate, and relevance to our user context. We also created micro prototypes to test assumptions before committing. Parallel to this, we addressed one of the biggest hidden challenges: data structuring. We inherited a disorganized collection of Word documents, each formatted differently and lacking metadata consistency. Turning these into a usable system required more than just passing text. It demanded thoughtful categorization and design logic. We compared formats like XML, JSON, and YAML before settling on YAML for its readability and ability to represent nested structures. We created a schema that captured metadata, which were the name, description, and tags, the user dimensions, which was the engagement level and the scale, and modular content blocks that could be selectively edited. Each document required contextual analysis, which were what parts were variable, what needed to remain fixed. Our supervisor's feedback played a key role in this process, helping us align technical decisions with participatory design principles. This phase reminded us that even simple sounding tasks like converting files become complex when they intersect with real-world usage. Structuring these documents wasn't just a software challenge, it was an act of knowledgeable translation requiring both technical rigor and domain sensitivity.
So, with our data pipeline and technical foundation in place, our third sprint addressed what became the most complex and revealing part of the entire process: integrating AI in a way that is context aware and structurally reliable. Our primary objective was to enable template customization through natural language processing. Users were able to describe a change, like adapt this workshop for 20 participants in, say, an online setting. This would then allow the AI model to process the existing template and allow the user to receive a modified template that respects the original structure and methodology. So we began with Tiny Llama as a lightweight local language model that offered privacy and fast performance. Unfortunately, it consistently misinterpreted the prompts and erased content, and the output was unrelated and often had incomplete responses. So we quickly realized that we had underestimated the contextual limitations of these smaller models. So this led us to adopt Gemini API of Google, and it was a much more powerful cloud-based model with better comprehension of instruction-driven tasks. But the transition wasn't really plug and play. We had to develop a nuanced prompt engineering strategy, and we had to write highly specific instructions that preserved the headers, formatting of the workshops, and the limitation of the scope of changes that are possible. So that ensured that our theory and the literature that we have read are still respected in the modified versions and limits the hallucinations that is produced. So to ensure the reliability, we built a suite of validation tools and testing scenarios. Over 15 test cases were built with varying degrees of complexity. And initially, our pass rate was just 40%. So we iterated on prompts, we introduced fallback mechanisms, and we developed a way to display the AI edits transparently so the users could verify the changes before accepting them. After these adjustments, our pass rate rose above 85%, a success that we attributed to both technical tuning and structured feedback-driven iteration. This process taught us how different AI is from conventional code. In our previous milestone, we discussed a conventional code of writing and developing the website in HTML, a little bit of Python, and mostly JavaScript. So these errors that we experienced there were syntax based and a little bit logic based. But here the errors are interpretative. We can't just debug an AI model in the traditional sense. We have to revise the language, rethink the context, and revise for the plan or ambiguity that it's producing. So we learned to stop treating the model as a back-end function and started treating it as a collaborator, sometimes brilliant and sometimes unreliable.
As we move deeper into the fourth sprint, we shifted our focus from back end architecture to front end experience. This was the space where everything we had built, the AI, templates, and structure, had to be made accessible and intuitive for actual users. Our original workflow was technically sound. There was describing the use case, selecting template, editing variables, and refining output. But when we tested it, the structure fell apart because users didn't follow the path that we expected. They wanted to engage conversationally from the start, not through a rigid, segmented interface. We went back to the drawing board, and after reviewing user feedback and insights from sprint check-ins, we restructured the interface. Now, after describing the use case, users can choose templates based on two filters, like scale, which was individual group or a large community, and engagement level, which could be low, medium, or high. These dimensions match real-world planning decisions and improved clarity. We built a two-column interface, one for the conversational exchange and one for the live preview of the evolving template. This mirrored the mental model of a designer iterating as they reflect. We also encountered a usability issue that at first seemed trivial. Buttons needed to be clicked twice to respond. But after deeper inspection, we found that this was due to how Streamlit handles reactivity and script reruns. Fixing this required us to revise our state management and revalidate user inputs across every interaction. This phase solidified an essential insight. Interface design isn't about what's logical to the system. It's about what's intuitive to the user. Our sprint reviews helped us see patterns of confusion that we would have otherwise missed from within the codebase. That feedback loop, observe, reflecting, and improving, was invaluable.
Where theory met practice. Our goal was to move from a functioning local system to a secure, reliable, cloud deployed application that users could access without technical friction. Security was our first concern. In earlier builds, we had hard-coded API keys, a huge vulnerability. We transitioned to using .env files for local development and Hugging Face's secret manager for deployed environments. Each setting required careful attention to the timing of variable loading and scope access. Deployment itself was surprisingly difficult. What should have been a simple git push became a series of roadblocks. We encountered repeated authentication errors, broken file hierarchies, and unexplained deployment failures. Eventually, we discovered the root cause. We were mistakenly uploading the entire venv file. This bloated the repo and triggered errors. Once we removed it and uploaded our .git ignore, things ran more smoothly. After those issues, we opted for a manual upload process, lower yes, but reliable. We recreated the folder structure, reconfigured environment variables, and ensured dependencies were clearly defined in the requirements.txt folder. We then built a deployment checklist to document these lessons for future use. The sprint wasn't just about deploying an app, it was about developing maturity. We learned that the final stretch often takes the most effort. We understood the value of parity between dev and production environments. We became more attentive to small details with big consequences. Looking back across all four IEX2 milestones, we see a transformation not just in the product but in ourselves. We moved from idealists to implementers, from speculative thinkers to systematic builders. These milestones weren't simply about tracking progress, they were transformative checkpoints that forced us to clarify what we wanted to create and how we wanted to create it. Thank you for your time. We hope this presentation gives you a window into both our product and our process, each strengthened through structure, feedback, and focused iteration.